What a beautiful demonstration of the power of rhythm by this audience, without any instructions. Beautiful. We know this so well from ECG signals that reflect the rhythm of the heart. You see a normal one here. If I show an abnormal one, it gets a bit scary. This one is not in good shape. If I project the X-ray image on top of this, it's intimidating. You clearly see this heart needs help. And that help can be offered from cardiac ablation. Using a catheter ablation, you can isolate specific parts in the heart that block then the irregular signals and turning the heart back into normal rhythm. You basically turn tissue into scar, and that's happening inside the heart. It's moving, it's in the dark, the physician don't see enough. So there's a problem associated with cardiac ablation. It's a very good curative treatment, but 1 in 3 patients have to come back for a repeat procedure to become symptom-free within 1 year. This goes at the cost of a lot of money, of course. Hours are spent on existing patients, not on new patients, while we have waiting lists. And also the patient is totally unhappy, even maybe deteriorate even further with such a heart. What if we could provide vision to the physician during the procedure? That's exactly what sonic precision will try to do. We take deep technology, using an ultrasound sensor, we put it inside a catheter. Yes, it's really there. We then make sure that the wires come out of the catheter again to connect it to the readout system. This readout system is a very complex system that does all the signal processing of it. We can then start imaging and we give feedback to the physician during the procedure. Technology we licensed from Philips, except for the catheter, that's something we work on ourselves. And this has been shown very positive for different clinical features. We could measure contact, we could measure wall thickness, we could see catheter stability during the procedure. A beautiful recipe for the new technology pulsed field ablation, which is taking the stand at this moment in cardiac ablation. And this is the team that's helping us to build this recipe. There are a lot of physicians that are ready to help us now, and in the rest of our journey, we also talk to the big EP giants that bring these products to market. This is the team that's working on this. We've done this before. We've brought medical devices to FDA clearance before. We have strong electrophysiology knowledge. We have strong medical innovation knowledge. And this team is going to bring this business case to the market that reaches a business of 1 million 5 years after introduction. Yes, medical technology takes a long time. You have to develop it first, then you release it, then you bring it to the market. After 5 years, through a distribution model, we hope to reach 100 million. To realize this journey, we are seeking a seed round at the moment because we want to develop the technology to a first-in-human status and build out our relationships with OEM partners as a distribution partner. 6.5 million is requested, partly will be come from governmental loan, and we hope to fill this round this year. This one I wanted to show. So in conclusion, sonic precision brings ablation from assumption to precise intervention. We want to create vision during the procedure. You're invited to join us in this vision. Until that time, keep your rhythm. Thank you.
Of course, I knew what was coming because we practiced this morning, but still was quite surprised by how rhythmic Rene is always moving.
And I want to thank you for the drop, by the way, because drop is good for our business. And it's not so good for your blood pressure.
Yes.
Blood pressure is not so good for your heart.
It's a self-fulfilling prophecy. Yeah, we're happy with that, I think. Our investors, our jury, go for it, Patricia.
Yeah, you're asking for 6.5 million to get to the first in human.
Yeah.
It seems a bit a small amount. I guess normally it will take a lot of more money to get FDA approval and further. How do you see that road?
We benefit a lot from all the investments that Philips has done, as we are a spin-out of Philips technology. So a lot of the materials have already been de-risked. So in that sense, we can build on a lot of technology that has been done, and we upgrade that to the level that is needed for first-in-human study.
How much money do you think you need after that? What's the next round?
The next round would be 20 million to do the full first-in-human plus the early feasibility study to shape the pivotal trial. And then your next question would be, and after that, something like 50 million. That's the entire journey of medtech journey inside deep tech. Some CEO said to me, Rene, collectively we fallen in love with the wrong technology within deep tech. Medtech is so expensive and takes so long time. It's part of it.
I heard Philips. Can you maybe elaborate a little bit? Is there a relationship, and what's the IP landscape looking like? I mean, you have your own IP.
So we are a spin-out of Philips. So they are a minority shareholder in the company, a minority stake, and we have exclusively licensed the key patents that we need to bring this technology to the market and protect it beyond the introduction that we have planned for. So I think we're good from a shareholder perspective and from a patent and technology perspective. We have all the data, all the know-how, all the publications ready at hand to make a flying start that Patricia was alluding to that needs to be done, otherwise you won't make it with 6.5 million.
Go for it.
I have a question related to the compatibility of your system with the robotic units or the system used in the surgery. Do you need to be compatible with the systems there? Are you working on having them integrated?
Correct. The CAT lab where these procedures take place have a certain expectation on what is compatible. So you need to know where you are with your catheter. You need to have electrical mapping that you know what tissue should be put into SCAR. We should be compatible with this, and we have these conversations with OEM partners to see how we can be compatible.
And do you have to be compatible with the Medtronics and the Philips and all of them, or are you going to choose one and you're going to work strategically with?
Ultimately, you choose one because then you have your exit strategy. Because working with everybody is diluting your parts. So we pick the best one to start working with, but try to keep your independence until you realize your exit strategy.
Good. That also concludes the Q&A. What was again vision and precision in the physician?
Sonic precision provides vision to the physician, a real tongue breaker.
Yeah, very good. Thank you, Rene.